Alright, good day. Today we're going to go over 5.7, using congruent triangles. It's the last chapter in our Unit 5. What you're going to learn today is to use congruent triangles. I don't believe we'll get into proof constructions. We'll know as we get through it. What this means is you're going to use the information you've gleaned so far in Unit 5 to prove congruent triangles in real life situations. It's important that you note something first. There's a statement called corresponding parts of congruent triangles are congruent. And that is abbreviated as CP. Corresponding parts of congruent triangles are congruent. I'll write that out really quick. In essence, what that means is if you prove two triangles to be congruent by one of the 5 theorems that we discussed in the previous chapter, ASA, SSS, etc., I'll show an example. Let's say we prove two triangles congruent by SSS. Okay? We've shown all sides are to be equal, so these two triangles are congruent. So by this phrase, corresponding parts of congruent triangles are congruent, what that means, and it should be obvious, but it means it just is a lot of words to state it, is if I've proven these two triangles congruent by SSS, that means this angle are congruent, this angle are congruent, and this angle are congruent. So once you prove two triangles congruent with 3 of those things we discussed, the rest of what we haven't proven is also congruent. So we here have an example, a real world example of using congruent triangles. It says, explain how you can use the given information to prove that the hang glider parts are congruent. So I'm going to zoom in on this hang glider. Something that is on my bucket list to do, to be honest. So they give us 2 things you see down here. It says, given that angle 1 equals angle 2. So let's put that in here. Angle 1, I don't like that color. Let's get a color you'll see better. Angle 1 is congruent to angle 2. And RTQ is congruent to RTS. RTQ is this angle, is congruent to this angle. Then it says, prove that QT and ST are congruent. So it's one is to prove that these 2 long legs of that triangle are congruent. What you need to do then is you need to fill in the information of things that you know. Now, we already know that these 2 angles are congruent. By now you should quickly see, for these 2 triangles, they have a shared side, RT. So I've got an angle and a side that are congruent. What I need to find out is, can I prove something else to be congruent? The other information they gave us is, angle 1 and angle 2 are also congruent. Now, those angles are not inside the 2 triangles, they're outside of it. However, you should know by now, angle 2 forms a linear pair with angle S, and angle 1 forms a linear pair with angle Q. And since angle 2 and angle 1 are congruent, those angles they form are also congruent. Right? Because whatever adds up to 180 here with this will be the same thing that adds up to there by the rules of linear pairs. So now what I've proven, I've got a side that's congruent, an angle, and an angle. So it is congruent by what theorem? AAS, right? Angle, angle, side. Remember what we've been asked to do. Prove that QT is congruent to ST prove that this is congruent to that. Well, we've proven these two triangles to be congruent, so by what I wrote on the board, corresponding parts of congruent triangles are congruent. If I know these two triangles are congruent, then these corresponding legs, ST and QT, are also congruent. That's what we've proven. So, here what this might be easier for you, rather than work with the image with all of its extra distracting things, the color of the glider and the thing he's riding in. What they did in the example is, they just took apart the two triangles and wrote in the information. So just quickly reviewing what they wrote in. They wrote angle 1 and angle 2 is congruent, and the two angles given to us to be congruent, right? And then we found, because these are linear pairs, this angle and that angle are congruent, and then the shared side here, so we have angle, angle side. All right. So here's where we're going to have the substitute pause. I want you to explain how you can prove that angle A is congruent to angle C. Prove that angle A is congruent to angle C. So sub, please pause at this moment. All right, and we're back. So what you see here in this image, our goal, can we prove these two triangles to be congruent? And if so, by what theorem? Well, I've got a side and a side that are congruent, and another side and another side that are congruent. So can I prove anything else about another side or an angle? Hopefully by now you can see very clearly we have a shared side. So BD is congruent to DB. So these two triangles are congruent by side, side, side. And then because CP, CTC, corresponding parts of congruent triangles are congruent, I can then state that angle A then is congruent to angle C, because those two triangles are congruent. That's all you're trying to do here. All right. This is very interesting, using congruent triangles for measurement. So, this says, use the following method to find the distance across a river from point N to point P. And I'm here to tell you, this method was used extensively until we created such things as laser systems to help us take measures across great distances. Before that was involved, if you wanted to measure the distance across a large river, rather than sending someone swimming across the river and possibly drowning to death, you could use your knowledge of congruent triangles to do an indirect measurement across that river. And we are going to do this as a project when I get back. So here's what you do. You're on this side of the river. You find a point across the river on the other side, some landmark, something that stands out that you can see, a giant tree, a telephone pole, whatever it is, it doesn't matter, but something that is distinguished that you can keep your eye on. You come directly across from that on this side of the river and you plant a stake at N. You put a stake in the ground. Then you measure 90 degrees from that straight across and you go alongside the river. Doesn't matter how far, pick your distance, doesn't matter. You go to that distance, you plant another stake at point K. Put a stake in the ground at point K. You now measure your distance between N and K. Cut it in half. Figure out what the halfway mark is. Measure that halfway mark and put another stake in the ground at the halfway point at M. So we have 3 stakes in the ground right now. We have N, we have K, and halfway between them we put M. The last step to this is this. From your stake at point K, you measure 90 degrees from that, and you walk back along from that 90-degree line until, with your vision, you notice that the stake at the midpoint is in alignment with whatever you had stated across the river to be your designated landmark, whatever it is. So you keep walking, you're looking, you're walking, you're looking, you're walking, you're looking, until when you look back, you see that stake and that landmark are in alignment. And when that is the case, you stick one more stake in the ground at L. 4 stakes, N and K, halfway between them is M, and then 90 degrees away until you get these in alignment. So now you've created 2 right triangles. So what we ask ourselves is, can I prove these 2 right triangles to be congruent with one another? Well, we know we have 2 right angles. That's clearly equal to each other. And since we took this line and split it in half, we know this length and this length are also equal. I need one more thing to prove these 2 triangles congruent. I'm hoping you all can see it. Now, you may think hypotenuse lay because it's a right triangle, but that's not the case here. What we have instead is vertical angles. Because these angles are vertical, they're equal to each other. So now I know these triangles are equal to each other because of A, S, A. Last thing, because I know these 2 triangles are congruent to one another, I then can say that the distance N to P is the same as the distance from K to L. So I can measure this distance from K to L safely on the ground on this side, and it will give me a pretty decent idea of how far it is across the river without actually having to cross the river. So this is a very practical way of how we measure distances across something indirectly with our knowledge of congruent triangles. And we're going to do this as a project, like I said, when we get back. All right. Last thing I want to, I believe this is the last thing to do. Let me just confirm that really quick. It is. Last thing I want you to see your way through is this. It says here, use the given information to write a plan for proof. Given that angle 1 is congruent to angle 2, and angle 3 is congruent to angle 4, prove that triangle BCE is congruent to DCE. Okay? We've got those 2 little triangles. Let me erase that and go back, and I want you to notice, of course, here, we've got a bunch of triangles in this picture. We've got at least, let's see, 1, 2, 3, 4, 5, 6, 7. We've got 8 triangles here in this image. 1, 2, 3, 4, 5, 6, 7, and 8. So, what we're trying to do here is prove these 2 smaller triangles right here are congruent. In order to do that, we need to prove a bigger triangle congruent, and then use our CP/CTC to prove that these triangles are congruent. And let me walk you through that. So let me show you, let me highlight 2 bigger triangles. We've got triangle CDA, which is here, and we've got triangle CBA, which is here. Okay? These 2 triangles. Notice these 2 triangles have 2 angles that are equal. If I can prove one more thing congruent, I know these triangles are congruent to each other. Let me erase. What I want you to notice is they also have a shared side between the 2 of them. So then those 2 triangles, CDA and CBA, are congruent to each other by angle, side, angle. And so what that means is, if I erase everything, is all congruent parts of those triangles are also equal. So CD and CB are congruent. DA, and double there, shouldn't have, there we go. DA and BA are also congruent, because we've proven these 2 big triangles to be congruent. Now, let's go back to our, what triangles we're trying to prove congruent. We're trying to prove CDE and CBE. these two small triangles. I'm going to erase that purple. Please notice, so far with these two little triangles, I know these two angles are equal. I know these two sides are equal. I need one more thing. What I'm hoping you noticed here is they have a shared side between the two of them. So then I have proven those two triangles are congruent by SAS. Okay, it takes 2 steps. We had to prove 2 bigger triangles congruent first, and then because corresponding parts are congruent, we now can go back to the smaller triangles and prove them congruent as well. It's a 2-step process. I know there's no math involved here. Conceptualizing is going to be the key to success for you in this lesson. What I'd like you to try to do, this is a complicated problem, not going to lie to you. It says write a plan to prove that triangle PTU is congruent to UQP. We want to try to prove those two triangles congruent. All right, what I want you to notice before I pause and have you try to work through this, what I want you to notice is, look how many triangles that we have in this image. And ask yourself, can I prove any of these particular smaller triangles congruent first? So I have 1, 2, 3, and 4 triangles very clearly. However, I also have a big one here and a big one here. I have 6 triangles in this image. So you want to see what you can do to prove the 2 big triangles are congruent by working with the smaller triangles. So let's go ahead and pause here for a moment, substitute. Guys, I want you to try to work with each other, separate out the triangles if you need to, and try to work through this problem. Do that now. Okay, so we're back. The key to this is you need to focus on the smaller triangles first. So let's look at this triangle, PSQ and TRU. Let's try to prove those 2 triangles congruent to one another. Okay? Very clearly, they have a shared side, right? Here's how we know that. Now, here's where it gets a slight bit tricky. They sort of share this side, but it's kind of split. But notice the split. These split parts that aren't common are equal to each other. The tick marks tell us that. And then they have this shared component as well. So what that means is these 2 sides are congruent to each other. Oh, let me just use triples. 1, 2, 3. Okay, and then if this is a 90-degree angle, that means this is a 90-degree angle. If this is a 90-degree angle, that means this is a 90-degree angle. So we have 2 right triangles. Please notice now, what I told you to remember to think about is if you have right triangles, which of those 5 theorems from the previous section should you think of first? It was hypotenuse leg. So I know here's the hypotenuse here, here's the hypotenuse here, and here's the legs that are congruent. So those 2 triangles are congruent by hypotenuse leg theorem. So if those 2 triangles are congruent, then what that means is this QS is congruent to this RT. Now we look at these smaller triangles here and here. Okay, so I've got 2 small right triangles. I know these legs are congruent. I know these legs are congruent, and they have an angle congruent in the middle. So these 2 triangles are congruent by SAS. And because they are congruent by SAS, that means then that here and here also congruent. So, remember what we're supposed to be solving for. And I know this is complex, we'll talk it through when I get back. This triangle congruent to this triangle. Okay? Now we've got these two sides are congruent. These two sides are congruent. And they share this side. So by side, 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 the two big triangles in question are also congruent. I would suggest, I'm going to post this on Canvas, rewatch this, work through it, go to some videos I'll post as well to help you see things through. It's not math, it's understanding what you see and how you work from one step to another using this corresponding parts of congruent triangles are congruent. And that is all we're covering in this lesson. So I'm going to turn it over to you now to complete your homework that I have assigned to you. We're not going to worry about constructions, okay? So thank you, have a good day, I'll see you when I get back.